When managing a national park, to allow for increasing tourism in the park while allowing the park to sustain for many years, the rangers must learn and know the traits of the forest rather than trying to study each and every one of its million trees. IT world of today and tomorrow is getting bigger, already encompassing millions of configuration items, and the number of possible configurations becomes almost infinite. This is intensified by the virtualization technology, which allows altering the server's virtual hardware within a few clicks. We understand that to remain manageable, the IT must standardize around known configurations. This helps reducing costs, as reducing the number of known configurations that should be supported also means reducing the amount of knowledge, procedures, and personnel needed in the IT organization to maintain those. Standardizing around known configurations also helps lowering the risks, as it improves the predictability of the impact that changes to the well-known configuration will have. Mature organizations are already aiming for this. Automation, virtualization, and service provisioning provide the customers with the means of deploying standard configurations. How can they make sure, though, that the environment stays standardized? Our solution exposes the mess by automatically eliciting common patterns of existing configuration. This is a capability that was developed in collaboration with HP Labs and provides the customer with visibility to the level of standardization that currently exists. Then our solution helps tidying it up by automatically coming up with a suggestion for the configuration standards that would make sense for the customer. The customer can then open RFCs to standardize around those suggested standards, and so both reduce the amount of existing configuration standards and reduce the amount of non-standard CIs. Last, our solution helps keeping it clean and making sure the environment stays standardized. This is done by alerting when there are new configuration drifts for the managed baselines. Let's see how this works. I'll start by selecting the environment that I wish to analyze to elicit segments of similar configuration. I'm selecting my QA environment, all 170 CIs in it, and I'll click the Generate Segments button, and after about 2 seconds the system comes up with a suggestion for the segments, the currently prevailing segments. You can see here those here in the pie below. We can drill into each one of those segments. For example, this one has 22 CIs, each one Windows 64-bit edition with Service Pack 2 installed on it, and 4 CPUs. Each one of those 4 CPUs is a 2.9 gigs CPU Intel Pentium 3 Xeon processor. You can see here another segment with 14 CIs, each one with 2 CPUs, and here 13 CIs with 1 CPU. Further down below the list I can see segments with only 3 CIs in each one of those. Let's look at the first one. This segment has 2 CPUs, similarly to the third segment, and has 2 gigs of memory, as opposed to the third segment, which has 4 gigs of memory in it. I can here take a decision whether I want to still keep this configuration to which only 3 CIs adhere, or try to standardize them by adding an additional 2 gigs of memory to those CIs and adhering to a more common configuration standard. This will help me tidy up my environment and standardize it more and more to reduce costs. I can also drill into the analysis for each one of those segments. For example, let's drill into this second segment with 22 CIs. And I can see again that all the CIs that adhere to these segments, I can see those that entirely adhere to this configuration standard and those 3 that do not. And let's drill into one of those. And we can see exactly what is the deviation from the suggested standard. For example, this CI is only with 32-bit operating system edition, while this one has 64-bit. I can then choose to open an RFC to align this CI with the proposed standard, and by aligning all deviating 3 CIs, I'll get my entire segment standardized. I can further slice and dice the information also from the standard dimension. Let's, for example, take a look at this CPU, which we can see that a few of the CIs do not adhere to. For example, here we can see that not all of the CIs on the left part has 2.9 gigs CPU speed. By clicking the details, I can see the CI that does not have 2.9 gigs. can see that it has 3.1 gigs, and I can choose again to open an RFC to align.ci with the more prevailing standard. I can take advantage of the feature that was already released in Configuration Manager and create a baseline policy out of the suggested standard, and by that the system will continuously monitor my environment for me and will notify me whenever there are deviations from the standard that I wish to enforce. By logging into my system, I can always see the standards that I wish to enforce and the level of conformance. I can now make sure I'm familiar with my IT environment. It is as standardized as needed, and it will stay in the future as I want it to be.